Welcome back. Greetings. Thank you for paying attention. We are now in session 6, and this is a stage in the data science pipeline where we talked about the data, the nature of the data. We understand different types of data, potentially where they come from. But at this time, those are raw pieces of data. We need to get the data ready. Let me explain a simple example in order for us to proceed with this stage. Let me share my screen. I want you to play a game with me for a moment, if you don't mind. This is a game. This is a kind of a sentences, and there are some potential words that you can fill in. Let's call this fill in the blank games. I used the to draw a picture for my mom. So you have book, run, turtle, globe, pig, ball, sing, song, jump, pencil, table, happy, sip, hand, house. I used the to draw a picture for my mom. This has been a sentence spoken or perhaps shown to you on a piece of a paper. Your brain now races to fill in the blank. The data is not complete. The sentence is not complete. I still could potentially say, I used the book to draw a picture for my mom. I used the ball to draw a picture for my mom. I used the happy to draw a picture for my mom. And this is a fill in the blank game. The data is coming and part of the data is missing. And the way your brain is going to work is that your brain, because you're now 2 decades in your life, maybe a little younger, a little older than 20 years old mark that we have discussed so far. And the idea is you have accumulated so many words, so many occasions, so many sentences that your brain is ready to match the I used the, something you didn't hear, something you didn't see, to draw a picture for my mom. So when I throw this sentence at you, your brain is going to say, okay, how can I fill this in? Maybe you used a pencil. I used the pencil to draw a picture for my mom. I used the table to draw a picture for my mom. How many times do you use the table to draw a picture anyway in 20 some years of your life? Obviously, you have been using pencil a lot. So basically, pencil seems to be a very natural gap filler, blank filler. So blank space, you have a blank space and you're filling it. This is what we are talking about. You have a data coming at you. This is a raw data. Sometimes it's missing. Sometimes basically it is coupled with so much noise. You are in a place among many friends, dinner table, maybe outside barbecue, and your mom is calling your name, David, catch up. So you didn't hear some of the words in between. There were so much noise in the area. People have been talking about and everything else. The noise is coming at you, and your mom voice is coming at you as well. You want to filter everything. You filter the noise around, you grab your mom voice, and you're going to say, okay, what did she mean? This is a barbecue. So catch up means perhaps she was saying, David, bring the ketchup. David, hand over the ketchup. So that's how we are talking about. So this is a natural process. You have been doing it now so wonderfully after accumulating so much during the so many years of your life. And now we want to formalize that process. Let me begin my slides. The data processing is the third of the slides that I have available for you. And we are going to discuss the data processing, pre-processing stage. And in this one, introduction to data preparation, we are going to talk about why we need to prepare the data, We want to take a look at the life cycle of data science and the data science project. We have already talked about feature engineering, but you could potentially expand upon it. We don't want to go into basically advanced knowledge of feature engineering. We simply want to alert you that feature engineering is going to add a layer of a skill to your success, because as you try to engineer the feature that you really need to actually process and then come to a conclusion, that's going to be a make or a break of your entire project. We are going to talk about data cleaning, data transformation, text processing, and some text pre-processing, and some text image pre-processing. So we really want to be in the pre-processing stage. We have spoken of structured and unstructured data. We talked about data as a vector. We talked about how to translate a text to a vector of numbers, graphical representations, images, and voice and signals. We have had that in second slide. What we want to do, we want to talk about preparation of data, data cleaning, integration, transformation, obviously, and reduction. We don't want to go too much, and we possibly are going to scan through some of the slides. We may as well avoid some of the advanced topic on data pre-processing stages. And we let you learn them when you go to the next stage and you take an advanced course later on. So this is part one. Let's start talking about data preparation. Now, first and foremost, I want to remind you once again about the data pipeline, the data science project pipeline. You have the raw data. We understood the nature of data. Potentially, we have made them structured data. Now we are going to do pre-processing. We need to do cleaning and a lot of other things. And then we are going to actually analyze the data and then have insights, reports, and visual graph. This pipeline has to be with you all the time. Irrespective of whether you're taking an introductory course or an advanced course, you need to actually consider this pipeline all the time. So data preparation is a process of gathering, combining, structuring, and organizing data in the way that it can be analyzed as part of data visualizations, data analytics, machine learning application. That's going to be the base. We will go into the next stage. Data preparation is the act of manipulating or pre-processing raw data into a form that can readily and accurately be analyzed. And it's going to be obviously an important part of the data science cycle. Why we need to do data preparation? Inaccurate data, most of the time it's actually a missing data, such as the fill in the blank game that I just played with you. You go to a doctor, to a medical doctor, and the doctor is going to take your heart signals. And the way they do it, they are going to put several sensors on your shoulder, on your chest, potentially on your arms, possibly on your legs. Those sensors are going to be attached to your body. They want to listen to your heart signals that are coming from different distance. So from arm to your heart, from your leg to your heart, from your different size of chest and your upper body to your heart. Those are important components for an expert to make analysis of whether you have an issue with your heart or not. And the way they do it is that they actually pick up a sensor, a physical sensor, and they put a kind of a glue, a very special type of a conductive glue, and then they put the conductive glue onto the sensor, and then they attach it to your body. What happens if your body happens to have a little bit of a hair and it's not properly basically erased and cleaned before the sensor has been attached? What happens if the sensor is a little bit loose? What happens if the conductive material is not actually performing the proper job? So what do you have? You have a number of sensors that are attached to your body, maybe I would say 8, and one of the sensors is not functioning properly. Can I still take the data that has been accumulated from the sensors, and then make a decision as to what could be wrong in terms of your heart, and after the analysis of your heart signals. That's what the intention. It could be a missing data. Different factors could cause that, continuity, data entry. That's another one. You have a drop-down menu. You go in and several of the drop-down menu, you put your first name, you put your last name. Possibly you don't put even your last name. You put your first name and it's David. And then you forgot to put your last name, or possibly you don't even want to do last name. You don't want to perfectly identify yourself because this is just a website you came across, you are curious, you want to log in, and they ask you for some information. And what happens is that you don't want to provide the full picture of your information because it's a domain you're not accustomed to. It's a domain you haven't seen in the past. So you do the first name, you don't do the last name. When I take a look at the data collected from the website, after the drop-down menu, I see one specific place that is going to be empty. I go inside. I'm supposed to say my first name is David. My last name is, let's say my last name is Johnson. Okay. But when instead of saying my Johnson, I'm going to say to the moon. That's my last name, to the moon. Now you can see how strange it looks like. I mean, the last name of a human being to be to the moon. And that would be kind of a data entry mistake in the data. It doesn't have to be a mistake. It could be even potentially a deliberate. And technical issues with biometrics, such as the example I just mentioned. The presence of noisy data outliers. There are many things when we talk about outliers. You are running. You and I are running. We go to the highway or on the sidewalk and we start running. You and I are running with a regular speed. We are not perfect athletes. We haven't been exercising as much as someone who has been exercising 10, 12 hours a day. Our speed is going to be a normal speed. And suddenly someone comes in, a world champion runner, and he or she is going to run, and obviously their speed is going to be noticeable. They actually run with the speed of bullet, I would say. So that means something is unusual. When you take a look at the picture, you see someone is running a lot more faster compared to a regular person. Then you are going to ask yourself, what do you do? How many hours per day do you practice? How many times per month or per week do you do running? These are outliers. Not only that, but the noise is different. You go to the beach side, you go to the barbecue, and you are interested in the voice of your specific loved ones, your mother, your girlfriend, your boyfriend, whoever your partner is, and you want to focus on the sound, on the spoken word of that loved ones. But at the same time, you have birds singing, you have ocean sound, you have the water sound, people are screaming, kids are laughing, and so many noise in the beach side. And then what happens, you need to be able to actually identify the data, the source of data and the data that you need to analyze. And sometimes it's a technological problem with the gadget. Well, electrical engineering, that's my expertise. And then we build something and the device itself is going to be noisy. I'm sure you have been listening to a radio station where the radio station is not clean sound. And you can see so many sounds coming in, something like that. And still there is a warning and you want to be attending to that warning. And that's very important message that is being broadcasted on the radio station, but it is coming with so much noise around, something like that. And of course, again, we could potentially enter the data. This time, it may not be necessarily a missing data. Rather, it would be a data that is even a comma. For example, I'm going to say David Johnson. And then when I say Johnson, I put a comma at the end. And when I put a comma at the end, the nature of the cell is going to change. I had name in my mind and suddenly I have a comma. I need to clean it. Johnson comma doesn't mean anything. Johnson, remember, every stage of these slides that we are talking about, we are actually talking in a computer language. Yes, yes, granted, you are an intelligent person and human being, but we are not talking about you. We are talking about computers. Keep in mind, computer says Johnson, comma, what is this? And then you say, okay, comma. No, you need to clean this up. You need to write the program to clean up the comma, okay? Inconsistent data, for example, in the presence of for example, you have duplication within the data. Again, human data entry mistakes is really common because especially when we are talking about structured data, where we are talking about database, and it is everywhere. Registrations in universities, government agencies, applications, entries, exit, whatever you call. And human data entry is actually going to have a significant impact on the stage where you want to make the data ready. There are ways that you need to actually clean them out. So when we talk about data preparation steps, there are many stages involved. I want you to take a look at the pictures on the right hand side. Clean up the data. Obviously, you have a data. It is mixed with noise. It's dirty data, I would say, with comma, with pieces of words and characters that are not supposed to be in that cell. You're going to take that and you're going to clean it up, and you are going to make the data shiny. In the sense that it's going to be really readily understood and readable without giving you an error. As a matter of fact, much of the time when you want to read a data that is available online from government agencies, from different sources where you are going to take a data set, usually they are not actually properly basically entered, and they are not really available for immediate processing. So you need to clean them up. Provide accurate data. You need to transform the data. So for example, sometimes the data is in one shape, but you are looking at the different aspects of the data. You are coming in as an expert and you're going to say, listen, I don't need you to tell me that my birth date is January 1st, 2000. I want you to tell me that your birth date is 0.1 slash 0.1, sorry, 001 slash 01 slash 2000. Maybe you want to have a different format, 01 dash 01 dash 2000. And basically what happens is that you might potentially do a lot of things during that transformation. You could potentially normalize. You could potentially change from a 3D to 2D and so on. Incorporate and adjust the data integration. So you do have different sources of data coming in, a data that is coming from left, a data that is coming from right sensors, and you're going to put them together and make them a cohesive, a meaningful data set that you want to actually feed into your program. You could potentially do data integration. Unify and scale data normalization is basically, especially when you are trying to collect the data from different sensors, different areas, and they may have their own standards. They may have their own minimum and maximum. And you want to have a comparative base between data, piece of data 1, piece of data 2. And in order for you to make that comparison possible, you actually need to normalize it. Handle missing data. Obviously, if anything is missing, how do you approach by that? Remember the fill in the blank example that I just mentioned to you. And the question is, how do you do this? Can you take a look at your memory and say pencil, book, table, and bring those pieces of basically words, those words in your mind, and then say, okay, this is the way I'm going to fill in the blank. How do you feel that missing data, okay? And then detect and manage the noise. It's really important for us to identify where the noise is coming from and how to eliminate them. You need to understand the characteristics of the noise and then say, okay, if I know what the noise function is in time, if the noise function is in frequency domain, I should be able to actually handle that and eliminate that. I want you to really be conscious about this pipeline, and that's why I want you to remember this all the time. Of course, they have been used and utilized in different segments of data science domain. In this case, it is about data mining, for example. You get the data database, you basically prepare the data, you transform it, whatever you do, you're going to mine the data, evaluate and present the data, and then you're going to make a conclusion. Once again, we talk about data pre-processing, data cleaning, data integration, data transformation, normalization, aggregation, generalization, and reduction. All of that is going to be part of the data pre-processing scenario. I'm going to discuss that in a moment. Let's continue with the examples of the slides. Missing data, noisy data, inconsistent data, outlier detection. So let's take a look at the examples that we have on the right-hand side. Lacking attribute values or containing only aggregate data. So for example, I wanted to put my occupation inside, I forgot. I'm a teacher. And instead of doing that, I simply left it empty. So this is going to be an incomplete data. Containing errors or outliers, for example, my salary is minus 12. How can I have my salary minus 12? If it is minus 12, you are possibly talking about the debt, the student debt, mortgages and loans, but this is not about salary. This is about your assets and your liabilities. So in place of salary, when I put minus 12, I made a mistake. Is this, by the way, $12 an hour? Or is this, if it was positive, was that $12 an hour? Listen, you asked me about my salary, and I simply thought that you're asking about my salary per hour. And I simply wrote 12. But that wasn't what the designer of the database and the drop-down menu meant for me to enter. The designer wanted to, meant that I should enter, for example, $2,000 a month, monthly salary. But I thought the designer is asking me to enter salary per hour. So that's a clear mistake. So when the database is prepared, you see many people are saying 1,700, 2,000, 3,000, 2,400, and so on. But then they see something called 12, even though it's not negative. And they are going to be alerted. What do you mean by 12 in that kind of a in the column? The age, I wanted to say 30 years old, and suddenly I made a mistake and I pushed an extra 0. So these are going to be errors, and they are typically coming from human errors. If we automate the process, for example, if you have a passport and you want to travel a little bit, as you travel from point A to point B and so on, you put your passport on the machine, and the machine is going to read, and hopefully the machine is going to do all of those kind of pre-processing for you, and suddenly you can see your name in a text format, not in an image format, in a text format, the expiry date of your passport, the start date of the passport, and so on. And they are all in text format. Who did it? The person who wrote the program to take the image of my passport and translate that to the text boxes so that I could potentially say, yes, the data is correct. No, the data is not. That's the pre-processing that the database manager has done behind the scene. Containing discrepancy in codes and names. Age is 42 and birthday is 03/07/97. Which one it is? You ask me about my birth, my age, and I enter birthday. You ask me about my birth date, and I enter the age. In the past, perhaps before the year 2000, everything was potentially numbered 1, 2, 3, 4, 5, and now the scale has changed. Now, for example, the grade. Take a look at your grade. The grade that you're going to achieve in any course, potentially depending on the institution you're in, you're going to see that the grade is in numeric up to the end of the term, and suddenly it's going to change into alphabetic numbers, alphabetic letters. So this transformation that is going to happen, and this could be potentially because of change of standards, change of approach, and you need to go back and fix them. And you could potentially have duplicate records, especially if it is not properly designed data entry. You could potentially have duplicate records that you need to get rid of. Here is a very good example of outlier and what we mean. As you can take a look at this outlier, and it's going to be a fundamental slide for us in terms of the nearest neighborhood approach. In a moment, we will be discussing that in this slide, series of slides. Keep in mind, take a look at this. As you can see, I have a center of gravity. This is the center point where I was able to manage to get the average of the x's, average of the y's, and then I found the center of gravity. And then I basically visually, keep in mind, we are human discussing this. And you need to be alert all the time with the difference of being a human and being a computer. As a human, your eyes are going to actually process this and say, okay, well, all of these seems to be within a very specific distance, or potentially given some parameters and variables in mind, I was able to confine them into this cluster. And that's going to be the cluster. You could have another cluster here and another cluster here. You have had some approach, methodology, and that approach has given you 3 clusters. And these points that you see that exist outside are going to be outlier. Okay, what is the regular salary of a person? What's the regular salary of a family? Now you have someone who is going to be $200 billion rich, to be $200 billion rich. That person is clearly outlier. That person is not like you and I. Why they have $200 billion wealth, that's a different story. But they don't fit with the regular definition of a family income. You know what I mean? So that's what this one is. So those are outlier, and we need to detect them. Take a look at this example where the integration is discussed. You have entities coming in from different sources, especially when we are talking about big data, when we are talking about metadata. We talked about metadata, by the way, in the previous slides. And you have an Excel file, you have a structured data set that is coming in, you have semi-structured data set that is coming in, and potentially you have non-structured data in the forms of text and tweets and document and everything else, and you want to basically integrate them. You want to make a sense. You can't just look at one dimension of the pieces of data that is coming at you. You can't just take a look at the Excel file and make a decision. You can't just take a look at the database, a structured database, and make a decision. Possibly, when you go to the medical doctor, what the medical doctor do? What do they do? The way they do it, they listen to your heartbeats. They listen to you and communicate with you because they are very intent to see whether you are coherent, you can speak, you know what you're talking about. They are going to take a look at your eyes, they are going to take a look at your mouth, they are going to take your temperature, possibly weight. That's a metadata. And how do you do that? In order for the doctor to understand my situation, my current situation, the doctor needs to actually take a look at my present states of mind, physical state and mental state, as well as look at the past medical record that I have, and then together the doctor is going to make the best judgment about what my medical condition is. So there could be potentially, for example, in terms of redundancy, there might be, the doctor may potentially take a look at my body temperature through the years, and then perhaps to put some temperature analysis through a specific device under my tongue. And that could be potentially redundancy. So the nurse has done one, the doctor is doing another one. I have high fever, and that's the way they are going to actually analyze whether I have a fever or not. And this would be a kind of redundant, but sometimes they may have to do redundancy. Data integration, what does it mean? Data A, data B, data C, they are of different nature, and you put them together and you integrate. That's the integration, data integration. Data transformation, aggregation means you want to add them together. You want to play with the data. You want to generalize the data. We are going to go through some of these in the future slides. Normalizations, numeralization, which is different. So for example, I want to say I'm happy, I'm sad, I'm angry, I'm thirsty. Those are statements, and I need to actually classify them, and I need to put them in proper place. So I would be numeralizing them. Normalization is another one. Discretization, much of the data that is coming at you, you expect them to be continuous, but they are not. You need to actually discretize, consider them either as discrete data that is coming at you, or even if it is continuous coming at you, such as the temperature outside on an open field, you need to actually discretize them and actually find the correlation with some other elements of the data pieces of data that you have. And data transformation, numerical transformation, and there is an example. So for example, I have some data coming from -2 to 48, and I want to normalize them. And the way I want to normalize them, I want this to be the maximum 1. So I'm going to divide everything. 100 is the maximum. I found what the maximum is in the data. It doesn't have to be 100. It could be 120. It could be 200. It could be 89. And the way you are going to do it, you're going to find the maximum, and you're going to divide everything by that maximum number. And then this will be kind of normalized. Well, of course, you keep in mind that this 100 or 200 or 89, sometimes you pick that up from the data. And sometimes you know the nature of the data that is coming at you, and you already know what that nature of the data has the maximum as the minimum. You already know that. You are an expert in the field, and since you are an expert in the field, you're going to divide that by the maximum minimum that you already know. Data reduction. The simplest example that we could potentially talk to you about is your cell phone. You're talking to someone else using WhatsApp, Instagram, FaceTime, whatever you do, and you have a high resolution camera. You have 10 megabits pixel, you have 20 megapixel, you have 100 megapixel, you have an extremely high resolution camera. Do you think that the entire image of you and the sequence of frames are going to be transformed, basically communicated to the other side with the same resolution? No. The way it's going to happen is that your image is going to be taken, your image is going to be compressed, and because the wireless channel doesn't necessarily allow you to go with 200, 100 megapixel anyway, you're going to send over maybe by 5 megapixels, and then the other side is supposed to basically get it back to some extent with the original resolution that you wanted to translate. So the way it's going to be is that you have a sample coming in, and instead of doing the huge sample, you're going to actually take a look at the smaller size. I want to know I want to project who is going to win the election in US. I'm not going to go and ask 350 million people in US as to what they are going to vote for. And by the way, whatever they say is not going to be whatever they do on the election day, right? So what I'm going to do, I'm going to only pick up 2,000. The best thing I can do is that now that I have done 2,000 on the West Coast, I can do 2,000 on the East Coast, I can do 2,000 at the North and the South, and some in middle and center. That's the best thing I can do. And the way we can do that is that you're actually taking a look at the smaller sample. So whether you are looking at the compressed image, compressed data, or a smaller portion of a bigger sample and population, you're actually trying to reduce the dimension and complexity of the data. Data wrangling, I want to actually explain this in a better way. So we have discovering, structuring, cleaning, enrichment, validation, and publishing. Let's take a look at my example that I wanted to discuss with you. This is coming from Wikipedia. Not that I always consider that a trustworthy source of information, no, but at the same time, there are things that we can potentially tap into, and there are trustworthy information, and here we are going to discuss. So you have a messy data. This is the messy data, and you're going to actually make them properly sequenced, and that messy data is going to be useful for you. But remember, more important than you is that you are going to make this ready for computer. Remember, computer is supposed to be faster than you. You need to talk to the computer that doesn't understand anything. You are the brain of the computer, by the way, and that's what is important. Now, discovering. The first step of data wrangling is to gain a better understanding of the data. Different data is worked and organized in different ways. You need to know the nature of the data. Find where the data is coming, what is, for example, the maximum, the minimum, how they are supposed to be sequenced. Structuring, the next step is to organize the data. Raw data is typically unorganized. I mean, your cell phone, your text, and everything. Take a look at the speech I have during this session. Take a look at your homework and assignment. Much of that could potentially be intentionally unstructured for a simple reason. They want to tap into your intelligence, and you're supposed to come and make it a structure. Raw data is typically unorganized, and much of it may not be useful for the end product. This step is important for easier computation and analysis in the later steps. Cleaning. This is all of these are part of data wrangling. All of these are stages and basically components of data wrangling. There are many different forms of cleaning data. We have spoken of some of them. You want to have, for example, remove the outlier. You have skew results. What does skew mean? Now, if you have a page and you have written your hand notes on it, you put on the fax machine, on the copy machine, and you take a copy, and it looks very nice, provided that you put it on the proper edge of the copy machine. What happens if the paper is slightly rotated? What happens if the paper is actually, you basically pick up the paper, you squeeze the paper in your hand, and you basically make sure it is completely squeezed. You put it on there. The words are not going to be seen clearly. So it's skewed. Skewed, we have talked about a skewed graph in the early stages of this class. Skewed is going to be a challenge in cleaning. As a matter of fact, it's a significant challenge. Enriching, determine whether or not additional data would benefit. This is you, an expert, and human, a human. You need to come back and say, listen, the data that you have collected so far is not sufficient for my analysis. You need to go back and collect this and this and this and this. Or listen, the data you have given me, you need to take a look at whatever you have collected. Potentially the client has collected millions of rows and columns of the data, but they are giving you just a piece of the data set. You're going to go back and say, listen, if you have collected this sensor output, I really need to see that sensor output. Okay, so you are, as an expert, you're going to actually come back and say, we need to enrich the data, validate the data. It's similar to structuring and cleaning, repetitive sequences of validation rules to assure data consistency. You can't say Johnson and then Johnson, comma. That doesn't work. Johnson is a last name. Johnson, comma, nobody has that last name. So you need to be very careful about that. An example of validation rule is confirming the accuracy of fields via cross-checking data. You could potentially see that every other name in the data set does not have a comma, and therefore you're going to make a decision, I'm going to remove that comma. Publishing, prepare the data set for use downstream into the machine learning process, into the algorithm, whatever you are going to do, the processing of the data, use of users and softwares. You need to document everything. So here is an example. Take a look at my table. This is a very nice example, and that's the reason I wanted to have this basically shown on the Wikipedia was this example. I liked it. Take a look at name. You have John Smith, Jennifer, Bill Gates. What? Is Bill the first name? Is Gates the last name? You have a comma here. And by the way, did you say last name, first name? Did you say last name, comma, first name? What did you say? Jacob Allen. Is Allen first name? Is Jacob last name? What did you mean? In this case, and this is one part in terms of name. In terms of phone number, I put a dash line. You gave me the freedom. By the way, you are a database designer. It should have been clear, perhaps using the helpline, the help button or something. How am I supposed to enter my phone number? You didn't oblige me to follow any format. And since you didn't oblige me to follow any format, I did my own thing. I said 445-881-4478. I had +1, 189. I had brackets and parentheses. I had basically no blank space. This is, nobody knows what this one is. As a matter of fact, I would consider this phone number completely out of the region. So if I take a look at this, I'm not sure if they are actually of the same format, but you need to take a look. So usually you have 8 digits for the phone numbers and then area code. So if this is not there, then it possibly is not one of the US phone numbers. Birth date, August 12, and then you have dash dash, and then instead of 1989 or 1972, I simply said 72. I use a dash line to explain, and I simply said January 3rd. And January 3rd, what does it mean? January 3rd what? 2000, January 3rd, 2010, January 3rd, 2021, we don't know. A state seems to be okay. Maine, Kansas, Alabama, but the problem is, instead of saying Texas, I said TX. Instead of saying Ohio, I said OH. It's not consistent. So when I want to take a look at this table, one of the things I would do is that this last row apparently is completely out of place. The phone number doesn't seem to match. The birth date doesn't seem to provide any information. And so I'm going to possibly put it in the queue, in a waiting list. I'm going to get back to that individual via email and alert them that your information is incomplete and you need to come back and fix it. The best thing a database designer can do is actually make sure that if I entered a format that is not acceptable by the database, it's going to actually make it red and say your phone number should be this dash this dash this. But if I have given the client the freedom to do whatever they want to do in the phone number case, I need to clean it up. I removed the comma. I said Bill Gates. I didn't say Gates Bill. So I'm assuming that John is first name and Smith is last name. Jennifer is first name and Tal is last name. Alan is first name, Fitch is last name. So I fixed it. Then in terms of phone, I actually made them all with the dash line. Birth date, as you can see, all of them in the same format. State, I didn't say OH, I said Ohio, okay? So this is an important segment of the slide, and you need to understand. And usually the data wrangling part is going to take a long time. You are going to have a lot of fun cleaning the data and basically taking a look at the data, how to enrich it and everything else. By the time the table is ready, by the time the data is ready, the rest, we have tons of libraries in Python. We have libraries in MATLAB. We have good students and researchers who have made all of those codes available. So 80% of the time is going to be spent on the data wrangling part. Then what do we do when we get the data? This is part of the pipeline we have been speaking of. Exploratory data analysis. EDA is a very important terminology. You are going to think of identifying the variables and data types, analyzing the basic metrics, non-graphical univariate analysis, graphical univariate analysis, and bivariate analysis. So in the data analysis, exploratory data analysis, you basically try to take a look at the data. Take a look at this. This is a reality. You're going to collect the data. This is going to be raw data. Data is going to be pre-processed, as a matter of fact. Data is going to be clean. You're going to do an exploratory data analysis. Then you're going to come back and have models and algorithms in place. And the models and algorithms are going to be the data product that is needed by the customer and client. And you could potentially communicate, visualize, and report, and make a decision and let your boss know, or let the organization and agency know what kind of policy you want to make. So this is going to be a studying the data. So when you have the raw data, when you do the pre-processing, when you have a clean data, you're going to start studying the data, and then you're going to basically either fit the model on, extract the model, and basically have a new model in place, and then you're going to provide the product to the client. We spoke of feature engineering in the past, and feature engineering in the past, of course, brainstorming and testing features, deciding what features to create, creating features. As I said, this is very important. Checking how the features work with your model. Maybe your model doesn't fit with the data coming in. Maybe you need to go back to the data and see whether you have to have a different model. I get this request and email every now and then that people are telling me, okay, the data set that is coming in is actually incomplete, not in terms of cell itself, but in terms of the column that are supposed to come in. They have provided only 5 columns. I need 6 columns. I need 10 columns. Improving your features if needed. Go back as basically brainstorming. So you have the data, you have the feature, you take a look at the model, and then you extract the insight. And this feature and data, they could go hand in hand. This is going to be a kind of a iterative process where you could potentially come back and change the way that the data is presented to your program. I'm going to stop, and then I'm going to talk about the basically data cleaning in the next recording. Stay tuned. We are going to go into next phase. Thank you.